What's up, everybody? Welcome back. And today I just want to quickly talk about multi-threading and how you can use it when you do variogram modeling. In this example, we will talk about using like a space-time sampling or dataset to compute the experimental model, the experimental variogram model using multi-threading, which is basically like having different channels of computations that are running one function at the same time to populate the vector. So let's just get right into it.
Welcome back. And yeah, so right now I'm just going to show you how I did it. You can see how long this file is, and I was definitely not going to do some, live coding to show you how it works. So the plan was to do it on the background, then have this recording just to explain the concept, right? So, as I said, what we are trying to do here is to show you how you can implement multi-threading to compute the to compute the experimental variogram model based on a data set that you are provided. And I will just go and explain the lines so that you understand a little bit what we're doing here. So basically, you have a data set which is like XYZT. In this case, we're doing some spatial temporal uh, analysis, and you need, and I have those XYT data in several files that I built a specific or customized file format to uh, collect those XYZT for different locations in a very big or very large domain. Now I can collect all those X over file, right? And each of them will give me a set of point clouds that I want to use to compute the experimental variogram model. So I need to know where those are located, which is here. And I also need this config file that I made just to tell me how many. So this is not really important for the purpose of this recording, but just show you. I need this file for some parameter. I have some parameters saved in this file, so I need them to do the job that I want to do, which is just collecting all those points into a single vector. Well, I have four vectors actually. One for x, one for y, one for the elevation, and the last one for the time values. Okay, so you read them, and you check if you have those files in the folder. If you have those files in the folder, you will go and read each of them and collect the data that you need. And that's what I was talking about when I said this is one of those, like this vector is collected from that config file. So right, so you read them, you collect the data, and at this point, I know how many points I have. Like it's redundant, but you find. So at this point, I know how much I have in terms of input. I know the size of my input data set, or like the size of my observations that I'm going to use. I do some transformation here just because you know for modeling purposes I do this, but you don't have to. This is not really what I want to show you. What I really want to show you is once you have done all this and you have a resolution for your experimental variogram, which is defined here, the multi-threading part is the most important, the one that I want, the point that I really want to show today is this part. Okay, so the way you do it is, one way of doing it. This is not the only way you can do it, but one way of doing it is you want to have a vector of thread, and you will populate each of each point or each element in this vector with a specific thread. And what will happen is within that channel of computations, you will run this variogram function for a specific lag distance. If a specific value in each lag is going to be running in a specific thread. So you populate this thread this way by just pushing back into this vector a specific thread, which is run this with this value for this position, basically. Once you do it, you you can actually, depending on how many times you want to use this vector, you can actually do it this way. This is the way I found it. I don't know. I found it easier this way. So I will run 20 threads, and I would wait for them to finish. Then I will go back, update the stack to count, and the stack from count 20 to 40. So 20 new threads until I'm done covering this vector. So when I'm done, if I'm not done, I start over again. This is very basic. Anyone who used, I think, I don't know if Pascal is using this, but I think the COBOL and assembly they use this. So this is a very basic instruction, which means I have an etiquette or a label over here. When I say go to, my code will just come right over here to start again. This is basically like when you use while this to do this, right? So I will run these threads a bunch of time depending on the size of this vector. But when I'm done, I can now uh, take the running time. Well, so the running time is something I skipped. The running time starts. So I want to know how long my multi-threading architecture. Oh, that's not really an architecture, but if you want it, you can call it that way. I want to know how long the multi-threading algorithm will take. So I start counting here, and then I end right after I'm done covering this vector, and I can display the running time. So I'm just gonna show you something. Hopefully you can see it. I have about 5 million points that I'm trying to compute, and I think for one lag distance you have 5 million to the square number of operation to do before you have the value, and you have to do it 200 times. So yeah, it's going to take some time before it's done, so I'm not going to wait until we are done here, but I just wanted to show you how it works. I have this much points, and I'm running the tool to get the experimental model from those points. So if you imagine doing this in a serial way, obviously you will just, I mean, you have bad plans for your computer. Multi-threading is one way of doing things in these type of situations, but it's not the only way. I can also use the GPU to speed up this process. GPU is actually pretty good if you have a good, let's say for example, you have a good NVIDIA graphic card. You can actually use your GPU to speed up this process. Sometimes those graphic cards will have like 2000 CUDA cores, right? So you can use those, and those CUDA cores can actually run a bunch of threads. So you can basically be running, I don't know, maybe let's say 10 times 2000. That's like 20,000, right? You can basically be running 20,000 threads in your laptop if you have a good graphic card. So yeah, that's all I wanted to share. I will probably come back with some updates if I have another implementation that you can use to solve this problem. Until then, see you next time. Ciao.